Welcome to this session on Chebeyshevs method. In the previous sessions, we discussed various methods to solve an algebraic or transcendental equations. Here we shall do another method, namely Chebeyshevs method. When the first and second derivatives of f of x can be easily found, and when an approximate value of a real root of the equation f of x is equal to 0 is known, a closer approximation to the root can be obtained by an iterative process as explained here. Let x r be an approximate value of a root of the equation f of x equal to 0. First we assume x r as an approximate root. Of the equation f of x is equal to 0, and let x r plus 1 be the exact root very close to x r, so that we can write x r plus 1 as x r plus h, where h is very small. Since x r plus 1 is the exact root of the equation f of x is equal to 0, we can write f of x r plus 1 is equal to 0, that is f of x r plus h is equal to 0, because x r plus 1 is x r plus h, where h is very small. Now, by using the Taylor series, by Taylor's theorem, we will expand this f of x r plus h, that is we can write f of x r plus h by 1 factorial into f dash of x r plus h square divided by 2 factorial into f double dash x r plus h cube divided by 3 factorial into the third derivative of f at x r plus etc. is equal to 0. The right hand side is 0. Now, we neglecting h square and higher powers of h in this expression, we can write f of x r plus h by 1 factorial into f dash of x r is equal to 0. We neglect the terms containing h square and higher powers of h. Then the corresponding equation will become f of x r plus h by 1 factorial into f dash of x r is equal to 0. This is equal to 0 approximately. Therefore, we can write from here f of x r is equal to negative of h by 1 factorial into f dash of x r, or h into f dash of x r. 1 factorial is 1, therefore, we can write h into f dash of x r is equal to f of x r minus f of x r, that is h is equal to from here we can write minus of f of x r divided by f dash of x r, that is h is from here we can write h as x r plus 1 minus x r is equal to negative of f of x r divided by f dash of x r, or x r plus 1 is equal to x r minus f of x r divided by f dash of x r. This is the formula we already discussed in the Newton-Raphson method. Now, to get a closer approximation to x r plus 1, by using this formula, we will obtain a closer approximation for XR plus 1. In order to get a better approximation to XR plus 1, we can omit the terms having h cube and higher powers of h in 1. Then from this we can write omitting h cube and higher powers, we can write this equation as f of xr plus h by 1 factorial into f dash of xr plus h square by 2 factorial into f double dash xr is equal to 0 approximately. That is f of xr plus h by 1 factorial means 1, therefore h into f dash xr plus, here in the denominator it is 2 factorial, 2 factorial means 2. We will substitute the value of h as in the previous step we obtained h as minus f of xr divided by f dash of xr. We substitute h is equal to minus f of xr divided by f dash of xr. In this term we can write h square means from here we can write negative of this square means it is positive, that is f of xr square into this f double dash xr divided by f dash of xr square, and 2 factorial means 2 into f dash of xr this square, which is equal to 0. By using the value of h as minus f of xr divided by f dash of xr in this term, we can write this equation like this. Therefore, from here we can write h into f dash of xr is equal to minus f of xr minus f of xr square into f double dash xr divided by 2 into f dash of xr square. That is f h is equal to from this we can write h is equal to minus f of xr divided by f dash of xr minus, from here we can write f of xr square into f double dash of xr divided by 2 into f dash of xr square into f dash of xr means f dash of xr cube. This is the value of h we obtained from this equation. That is, h means from here we can write h is equal to xr plus 1 minus xr, that is h square, this is f double dash xr. Therefore, we can write xr plus 1 minus xr, this is h, which is equal to minus f of xr divided by f dash of xr minus f of xr square, we can write minus 1 by 2 into f of xr square into f double dash xr divided by f dash of xr whole cube. Therefore, we can write xr plus 1 as xr plus 1 is equal to xr minus f of xr divided by f dash of xr minus 1 by 2 into f of xr whole square into f double dash xr divided by f dash of xr whole cube. This formula can be used as an iterative formula in order to get a better approximation of the exact root of given equation f of x equal to 0. This is known as the iterative formula used in Chebeyshevs method. Now consider an example. Find the positive root of the equation x cube minus 4x plus 1 is equal to 0 correct to 4 decimal places. Using this Chebeyshevs method, we want to find the positive root of this equation x cube minus 4x plus 1 is equal to 0. This equation is of the form f of x is equal to 0, where f of x is equal to x cube minus 4x plus 1, and this is our iterative formula used in Chebeyshevs method. Therefore, we want to find f dash of xr and f double dash of xr. Here f of x equal to x cube minus 4x plus 1, then f dash of x is equal to 3x square minus 4x minus 4, and f double dash of x is obtained by differentiating this, that is 6x. Now from here we can observe that f of 0 is equal to 0 minus 0 plus 1, that is 1, which is positive, and f of 1 is equal to 1 cube means 1 minus 4 into 1 is 1 minus 4 plus 1, 1 minus 4 plus 1. This is equal to 1 minus 4 is minus 3, minus 3 plus 1 is 1 minus 3, that is minus 2, which is negative. Therefore, by the location theorem, we can say that there exists a root in between 0 and 1. Therefore, we can say that there is a positive root in between 0 and 1, because at 0 the value of function f is positive and at 1 the value of the function is negative. Therefore, by the location theorem we can say that the positive root lies in the interval 0 and 1. Now, taking x naught is equal to 0, we take the initial approximation as 0, then f naught means f of x naught, that is equal to f of 0, which is 1, and f naught dash, that is f dash at x naught, which is equal to f dash of 0, which is equal to minus 4 from here. F dash of 0 is minus 4, and f naught double dash, that is f double dash at x naught, that is f double dash at 0, which is 6 into 0, that is 0. Putting r is equal to 0, we will obtain x1 as x naught minus f of x naught divided by f dash of x naught minus 1 by 2 into f of x naught square into f double dash x naught divided by f dash of x naught whole cube, that is equal to x naught is 0 minus f of x naught is f naught, that is 1, divided by f dash of x naught is minus 4 minus 1 by 2 into f of x naught square, that is 1 square means 1 into f double dash x naught is 0 divided by f dash of x naught whole cube, that is minus 4 whole cube. This is equal to, from here we can write minus of minus 1 by 4 is plus 1 by 4. This will become 0. Therefore, this is equal to 0.25. That is x1 is equal to 0.25. Now, we evaluate f of x1, f dash of x1 and f double dash of x1, and substituting in this formula, that is taking x1 as 0.25, then we evaluate f of x1, that is f of 0.25, which is equal to, from this we will obtain f of x1 as 0.0563. Now, f dash at x1, this is f dash of x, then f dash of x1 means f dash at x is equal to 0.25. We will get 3 into 0.25 square minus 4, which is equal to minus 3.8125. Now, f double dash at x1, that is f double dash at x is equal to 0.25, which is equal to 6 into 0.25, which is 1.5. Now, by this iterative formula, we can write x2 as x2 means when putting r is equal to 1, we will obtain x2, that is x1 minus f of x1 divided by f dash of x1 minus 1 by 2 into f of x1 square into f double dash at x1 divided by f dash at x1 whole cube. This is equal to x1 is 0.25 minus f of x1 is 0.05613 divided by f dash of x1 is negative 3 point, therefore, this will become plus 3.8125 minus 1 by 2 into f of x1 square is 0.05613 square into f double dash x1 is 1.5 divided by f dash of x1 whole cube means minus 3.8125 the whole cube, which is negative, therefore, this will become plus 3.8125 cube. On simplification, we will obtain this as 0.25410 approximately. Therefore, the second approximation is x2 is equal to 0.25410. Now, taking x2 is equal to this value and we evaluate f of x2, f dash of x2 and f double dash of x2 and substituting this formula, then we will obtain the better approximation x3, that is we take x2 as 0.25410, then f of x2, which is equal to f of 0.25410 from this expression, it will be 0.00001. and f dash x2, that is f dash at 0.2541, which is equal to, from this expression, which will be minus 3.80630, and f double dash at x2, that is f double dash at 0.2541, which is equal to 6 into 0.2541, that is 1.5246. Now, by the Chebeyshevs iterative formula, we can write x3 as x2 minus f of x2 divided by f dash of x2 minus 1 by 2 into f of x2 square into f double dash x2 divided by f dash of x2 the whole cube. Substituting these values, that is x2 is 0.25410 minus f of x2 is 0.0001 divided by f dash of x2, that is negative 3.80630. Therefore, this minus will become plus 3.8063 minus 1 by 2 into f of x2 square, that is 0.0001 square into f double dash x2, that is 1.5246 divided by f dash of x2 whole cube. F dash of x2 is negative 3.80630, which is the whole cube means again negative. Therefore, this sign will become plus 3.80630 whole cube. On simplification, we will obtain x3 as 0.25410. But in the previous iteration, the value obtained as x2 is 0.25410, and in this iteration also the value of the root is 0.25410. Therefore, the convergence attained, and we can conclude that the approximate value of the positive root is x is equal to 0.2541. This is the required positive root of the given equation, correct to 4 decimal places. With this example, let me conclude this session. In this session, we discussed the Chebeyshevs method, which is a method in order to solve an algebraic or transcendental equation. In this method, the iterative formula is x r plus 1 is equal to x r minus f of x r divided by f dash of x r minus 1 by 2 into f of x r square into f double dash of x r divided by f dash of x r the whole cube. And we have done one example for this method. Hope that you have understood this method. Thank you for listening the class. Have a nice day.